So hello friends, in this video we will talk about the Google BigQuery joins. Okay, joins. So Google BigQuery support all type of join like left join, right join, full join, self join. One second guys. Full join, self join. Okay, similarly way inner join. Okay, in similar way cross join. So all kind of joins is supported by Google BigQuery, like whatever the joins you are performing in any database. So same kind of joins we can perform here in data warehouse also. Okay, so but how to optimize join patterns? Okay, so firstly, uh, as an external, we don't need to mention anything. Okay, there are different ways to optimize join pattern, but externally we don't need to mention anything. Okay, externally we need to perform our left join, right join in background. Like Google BigQuery automatically optimize all the join patterns. So how it is optimized? So first kind of join is the broadcast join. Okay, so when we are using broadcast join, when we are joining large table with small table. Okay, then, sorry guys, when we are joining large table with the small table. Okay, so what happened then? BigQuery creates a broadcast join where the small table is sent to each slot processing the large table. Okay, so like then if we are not defining externally, then who is handling this kind of join, or who can show that? So in the video we have learned that Dremel technology is there, correct? In Dremel technology we have learned the tree based structure, correct? And in tree based structure we have learned about the query optimizer. So the query optimizer can determine which table should be on which side of the join. It is recommend the order to the join the table according to that. So query optimization is the best thing. It automatically handle all the things internally. We don't need to mention anything externally. Okay. So the best practice is the large table comes first, followed by the smallest table, and then by decreasing size. So always large table come first, and followed by smallest table. So means externally we don't need to mention like we are using broadcast join or any another kind of join. Only these left, right, full, self, inner, cross join, these kind of join we need to mention. But whenever we if we are talking about the optimization technique, so one is the broadcast join where the big table is there, we are joining with the small table, so then at that time broadcast join comes into the picture. Okay, so query optimizer automatically handle all this, so we don't need to take care. Okay, second things come into the picture is the hash join. Now, what is this hash join? Again, we don't need to mention hash join externally. No need to mention externally. All things handled by query optimizer. Okay. In hash join, what happen when we are joining two large table? BigQuery use hash and shuffle operation to shuffle the left and right tables so that the matching keys end up with the same slot to perform a local join. Okay, so whenever we are performing or joining two large table, then hash join comes into the picture. Okay, what it will do? It is use the like, or we can say that BigQuery uses the hash and shuffle operations. Okay, so in it is also working in the background. Okay, so but how we can define that like a hash join will work good? So if we are using or defining cluster by or clustering concept or clustering column, according to that, it will increase the overall efficiency of the shuffle data. According to that, it will increase the overall efficiency data. So ultimately, how we have learned till now two types of join. One is the broadcast join, another one is the hash join. In broadcast join, what happened? It is like one big table we are joining with the small table. Okay, but here we don't need to mention anything externally. It is all handled by the Google BigQuery, or in Google BigQuery we have query optimizer is there that can handle all the things. Okay, and similarly with the hash join is again when we are joining two large table, then hash join comes into the picture. How we can optimize hash join, because it is the expensive operation when we are joining two large tables. So via defining the clustering concept, then we can use the hash join so that it will be more good thing. Okay, third thing, self join is the thing which we need to avoid. Okay, why we need to avoid? Because it is again expensive operation is there. Okay, so that's why self join also we need to avoid that. Okay, and the another thing which we can say that there is one another join is there, skewed join. Okay, skewed join when happened, when data skew can occur when the data in the table is partitioned in unequal size partition. When joining large table that require shuffling data, the skew can lead to extreme imbalance in the amount of data sent to between the slot. So for example, we have partition the data. Okay, and that partition are unequal size. Okay, then what happened? Then this skewed join happened. Okay, so whenever we are joining large table that required shuffling operation. Okay, that can be lead to extreme imbalance. Extreme imbalance. Okay, so that's why to avoid the performance issue uh, associated with the skewed join or unbalanced join, it is also called as an unbalanced join. Pre-filter data from the table as early as possible or split the query into two or more queries. In that way it is possible. So till now we have learned like what kind of different joins we can perform. We can perform left join, right join, full join, inner join, self join, and cross join. So these kind of different join we have performed. How to optimize this? So BigQuery query optimizer is already there to handle to optimize over join. So there are the three kind of join generally he do internally. One is the like we can say that broadcast join, another one is the hash join, another one is the skewed join. In broadcast join, what happened, one big table is joined with the small table. Okay, so that automatically decided by the uh, query optimization optimizer. We don't need to define anything. So broadcast join already automatically handled by the query optimizer. Similarly, the hash join when it happen, when we need to join two large table. So whenever we are joining two large table, it's always expensive operation. Okay, so because we need to do lot of hash and shuffle operation there. So hash join, how we can make sure that hash join are uh, r- going in correct way. So we need we can use the concept of clustering, which we have learned in the previous video. Via that via clustering we are again dividing into the partition, so that can be helpful in the hash join. So whatever the column we are mentioned in the hash join in the clustering, so that in that way we can optimize over hash join. The third one is the skewed join. It is the unbalanced join where the partition data is the unequal size. Okay, so in that way like a large table required again shuffling operation, so extreme imbalance happen. So that's why these kind of join we can perform. Okay, thank you guys.